Hey guys, so today the Leetcode medium problem, sort colors. Let's understand the question first. So we are given an array nums with n objects colored red, white or blue. Sort them in place so that the objects of the same colors are adjacent with the colors in the order red, white and blue. We'll use integers 0, 1, 2 to represent the color red, white and blue respectively. So basically, yeah, you must solve this problem without using the library sort function. So we have three colors, and they have given them numbers, as you can see 0, 1, 2, and we need to sort the array. Now the most basic approach could be just sorting the array directly. They have written in the question that you need to solve this problem without using the library sort function. But if you really can't get the solution, even sorting directly works, and weirdly it gives the solution right away. So, right, okay. As you can see, so it's accepted. So if you don't really remember the algorithm, you could always do this. There's no, it's not, it works. Okay, so let's talk about let's talk about all the approaches now. Okay, so approach one. This is sorting the algorithm. Obviously, we shouldn't use this, but you can always use this, and it's brute force. And if you are in an interview, this really is not acceptable. Let's talk about the approach two. Approach two uses priority queue. So let's see. We all know what a queue is. What is a queue? Queue follows first in, first out. First in, it follows FIFO. So basically what we're going to do is we're going to maintain a priority queue. So we're going to maintain a priority queue. We're going to maintain a priority queue PQ, which we're going to run a loop and insert all the elements into this PQ. We're going to insert all the elements into this PQ. So let's see. Let's see the array is. Let's make how big is the array? 1, 2, 3, 4, 5, 6. Okay, let's make a table of 6. Okay, so now we have made an array. Let's number them 202 110 202 110. Okay, so basically what how the priority queue works is uh, it's the heap concept. It uses heap. So what you do is you you make a priority queue and then you run a which for loop through the entire array which uh, which pushes each element I equals 0, I equals 1, like this. It pushes each element into the queue, and after pushing it out, so this priority queue, it maintains the lowest number. It's a minimum heap, so it maintains the lowest number on top. So what you can do is after inserting everything in the queue, you can again run a for loop which is same iterations as the array, and you can just dequeue it, and you basically equate uh, you keep popping the queue until it goes null, until all elements are popped, and you insert it into the array in the ascending order, and that's how you get the answer. Okay, so let's code this. So make a priority queue int int and okay, let the name of the priority queue be pq. So now let's run a loop. uh it should be the size of the array, I mean the vector array passed. So now what you got to do is push it. So we're gonna do pq dot push. This is gonna push all the elements of the array into the queue. Now the top of the queue is the lowest number that is present inside the queue. So it will, if we pop, we'll get the lowest number. So run another for loop. And in this you equate nums of I equal to pq dot top, and then you do pq dot pop. Okay, so let's run and check if this works. Okay, so pq dot push is, oh, I forgot to nums of I. So yeah, you're pushing element. Forgot to put the element. Okay, so as you can see, it's running perfectly. Now submit. So this takes 3 ms time. This is 8.4 MB. And if you're really good with heaps, you can use this method. It's very easy and it's basic, and it's pretty fast too. So if you consider the time complexity of this, time complexity of this is for a PQ to access an element, it takes log n, log n time it takes to push and search in the queue, because this is in heap. So log n, so the time complexity of log n. And space complexity, we used one queue, so it is, that's the size of the queue is the size of the same size of our vector array, so it should be O of n, nums dot size, or O of n, or whatever you could say. That's a space complexity. Okay, so this is using queues. This is using queues. So let's talk now. Let's talk about approach 3. So the third approach is the we can. This is the most basic approach. Okay, like you can. So in this, what we do is, okay, let's see. This what we do is was yes, it was 202 202 110. So 110. So okay, so as we can see, there are three colors, and each color has been given one number. So the possible inputs or outputs, whatever you could say, no, the number of different distinct elements, the nums dot vector array is 0, 1, and 2. You cannot get any other number except these. So what you can do is you count the number of zeros, you maintain a count for each of them, and then at the end you just according to the count, just put them in the array. So all the zeros first, then the twos, and then the one, and then the twos. It's very simple approach. It's very basic. So let's give it a code. Ah, now let's see. Now for this approach, so what we're gonna do, let's maintain a count. Count for color 1, count for color 2, count for color 3. So these are the three counts. Now what we're gonna do, if we're gonna run a for loop across the uh, nums dot size across the array, and okay, now what we're gonna do, if we're gonna put if conditions, if nums dot size, so the only possible inputs are not nums dot size, sorry, nums dot I. So there are only three possible sizes, so you can just do this. Yeah, this is what we're gonna use there. Yeah, so it should be 2, should be 2, 3, should be 2, 1. Okay, so now we got a count of everything. Now what you're gonna do, uh the first the first file c1 is not equal to 0. Okay, so what you're gonna do, we are gonna run a loop nums dot I, not nums dot I. Okay, now let's okay, so in while loop, okay, so the concept is we need to we have counted the number of zeros, ones, and twos. So now what we need to do is, until C1, the count of the number of zeros we found in the vector array nums does not go to 0, you need to keep adding each position from the start of the array 0 and 0. I hope you guys get it. It will be clearer when you see it. So now, so basically, yeah, so basically, let me explain it more clearly. So you've got the three counts, okay? 0 count is C1, 1 count is C2, and 2 count is C3. So now you have an array. Let's see, we have the array. Okay, so this array, what you're gonna do is, now you have C1. Until C1 does not go to 0, you keep inserting zeros. So in this particular example, you can see that there is 1 and 2. There are two number of zeros. So the count of C1 is 2. In this scenario, the count of C1 is 2. So the while loop is gonna run twice, and then this position will get a 0 and this position will get 0. Now, next time now let's see the C2 count in the problem. C2 is a number of ones. The number of ones are 2. So C2 is also 2. And similarly, C3 is also 2. So now, after C1, after the while loop of C1 is done, we're gonna run a while loop on C2, and similarly, so it's gonna be 1, 1, and then C3 we're gonna run. It's gonna be 2 and 2. Okay. So nums of, let's maintain let's just call this F. No, let's call it let's call it like let's call it counter, or let's, yeah, counter counter's value is 0, so this we're gonna write counter here. So initially its value is 0. We can see that the counter, so nums of 0, that means the first element of the vector array will get the value 0. Similarly, we're gonna do this for C2 and C3 also. In this, it's 1 and 2. Okay, so now basically when is 0, we gotta increase the counter by 1, because then it will move to the next element. For each we have to do. Yeah, that's it. Segmentation false somehow. Oh my god. Good. Yeah, I forgot one part. So even the C1, the while loop would never satisfy. So C1 also you need to make. Similarly, C2 also. So it's you guys, it's so this, I'll explain out. Let me just write everywhere. Okay, let me explain. So basically, now we are maintaining a counter. So this is gonna iterate to all of the array. While C1 is not equal to 0, nums of counter. In this, the counter value is 0. And that's the first element. The first element is assigned the value 0. The counter is incremented, so it moves on to the next position. And see when the count of zeros is reduced by 1. Now, this keeps on going until C1 is reaches 0. So when it reaches 0, this loop breaks, and so it goes to the next loop. Similar thing happens, the amount of ones are inserted, and it just goes on. So yeah, so let's submit this. Yeah, so as you can see, it's accepted. Okay, now let's move on to the most optimal solution. Okay, so this is the approach 4. It is called the Dutch national flag algorithm. So this is the most optimal solution to sorting the colors. There's nothing more, there's no more optimal solution than this. And interviewers expect that you tell this algorithm for this specific problem. Okay, so what is algorithm or algorithm and how it works? So the algorithm has three main things. So it maintains three pointers, namely high, mid, and low. Okay, let me explain what. So let's take the array. So this array 2 0 2. Oh my, 1 1 0 1 1 0. Okay, so this is our array. This is our vector array. So now what is done? We use these three pointers, which are high, mid, and low. So we initialize low and mid to the first element and high pointer to the last element, the vector array. Now, so the initialization I'll write it down here. Last element, first L, and same. Okay. So now, so uh, okay. So what happens is, uh, we use a while loop which checks where if mid pointer is lower than high pointer, and if only this is the case, does it go inside the while loop. So now inside the while loop we have three conditions. So if first condition, if the element, okay, so if the element in this question, it's it's called nums. So if nums equal of nums of mid, the pointer mid, the element pointed by the mid pointer is 0, then we are going to swap uh, the low pointer with the mid pointer and mid plus plus and low plus plus. Okay, so this is the condition if nums of mid is 0. If nums of mid, so else if nums, okay, else nums of mid is equal to 1. Nums of mid is equal to 1. What we're gonna do is, okay, so if nums is equal to 1, we're just gonna do mid plus 1. So a mid plus plus. So mid plus, and else if nums of mid is equal to 2, then we are gonna do high minus minus. Okay, so how does this work? Okay, let's check it with iterations. So when these are iterations. Let's see, iterations. 1. Okay, so the iterations are so in iteration 1, what happens is, so when it goes to the for loop, so in while loop it checks first is mid lower than high. Is mid lower than high? Yes, it is true. That's therefore it swaps the element which is at position which is pointed by low. No, okay, wait. Yeah, so it checks this while loop condition. This while loop it checks. Is it being satisfied? It is being satisfied because a high value is nums size minus 1, the end element, and the mid is pointing to starting, so it's satisfied. So now it goes inside. It goes inside the while loop. Inside the while loop, then it checks the what element is mid pointing to. So mid is pointing to 2 here. So now what happens is in yeah, so it's pointing to 2. So it's if it's pointing to 2, oh yeah, there is swapping here. It swaps mid and high here. Okay, so if iteration yeah, the first iteration, so it's equal to 2. So now what happens is this mid pointer is swapped with the high pointer. So so this so now these two are exchanged. So now it's 2 here and 0 here because the pointed by the mid is exchanged, and mid and high is so mid is still pointing to this, but high has come down 1. High is pointing here now. Okay, so now again it checks the while loop condition. Again we can see that it's satisfied. Its mid is 0 and high is second last element. So wait, let's give iteration. I'll yeah. So 0 1, yeah. So high yeah. So this is fourth element, fifth element. High is fifth element. Mid is 0. High is 5. Okay. So now in iteration 2. In iteration 2, what happens is it goes into this, it checks this. Now it sees that mid element is 0. So when it's 0, what the program does it is swaps this 0. It swaps the 0 with, so what program, it swaps the 0 with the position pointed by the low pointer. So now 0 is swapped and the resulting will be the same because the same element is swapped. But both the the high, low and medium, both of these pointers are, okay, this is 0. Yeah, both of these pointers are now here. So mid has increased by 1, even low has increased by 1. Okay. Okay, if now it checks is now again the loop runs and the while loop is satisfied. Again it is 0. So again uh, these two are at, okay. So this is iteration 3. In iteration 2 this happens. In iteration 3 again, as you can see, nums of mid is 0, and that's why it's exchanged, and mid and low pointer are updated by 1. Okay, so now both come here. Now as you can see, mid and low. And now as you can see 2 is there. We are talking about iteration 4 now. In iteration 4 you can see that 2 has come, and still low is yeah, so 2 has come. So now 2 will be exchanged. As you can see, if nums of mid is 2, then we have to swap mid and high. So mid and high get swapped. So okay, mid and high are swapped, and then high is reduced by 1. The high pointer is reduced by 1. This point, so it points here. Okay, so high points here. Now, now the fourth iteration is on. Now fifth iteration. In the fifth iteration, mid value. Okay. Now in the fifth iteration, as you can see, mid is 1. So when mid is 1, it simply increments the I pointer. Sorry, the mid pointer by 1. And now mid pointer is here. This is greater than equal to. So yeah, so it's pointing to the same location where high is pointing. But now still the condition is satisfied because mid is equal to high. So now what happens is, again it runs, and as you can see that uh, the mid is pointing to 1 again. That's why as mid is pointing to 1, mid is incremented by 1 again. It is incremented by 1 again, and it points here. At this point of time, as you can see, this condition is not satisfied. So it exits after a while loop, and we thus get the answer. Okay, now let's code it. Okay, so we're gonna declare mid equal to 0, high equal to 1, and low equal to this is nums dot size -1. So it's pointing to the last element. That's why high is nums dot size, the size of the vector array -1. So now we'll run a while loop, which is our like base condition. If it fails, then the whole this thing is stop, execution is stop. Okay, so high should be greater than or equal to mid. Simple. Okay, so now we have the if condition. So if nums of mid, so we are always considering mid. So this is kind of like the 2-point approach. So equal to 0. Now when nums of mid is equal to 0, we are supposed to, so mid is 0. We are supposed to increase mid and low by 1 by 1. First, yeah, and we need to first actually, yeah, I didn't say the correct. First, you need to swap them. First, you need to swap the elements pointed by mid and element pointed by low. So low basically collects all the zeros and high collects all the twos. and mid is just a pointer which moves along the array and puts everyone in the correct place. Okay, now if nums of mid is equal to 1. So now, as I said that low collects all the zeros, and high collects all the twos. Mid is just trading to the array. So if it encounters a one, it just need one just needs to be in the middle. So nothing happens when one is encountered. Only mid plus plus. So if mid equal to 2, so if mid is 2, then you have to swap nums of mid and nums of the elements pointed by mid and high. You gotta swap them, and you just gotta do high minus minus. Oh, silly mistake. Okay, so it's working now. Let's submit and see. Yeah, so it's accepted. So this is the famous Dutch national flag algorithm problem. This is asked a lot in interviews, and this is the optimal solution for it. Hope you have understood.